All right, so we're going to do the nitrate ion here. And a lot of people get confused because they see ion and they think ionic bonding. Remember, an ion is just a particle that has a charge. Okay, nitrate we know is NO3 minus 1. That's how he gets credit for being an ion. He is definitely an anion because he has a -1 charge. Okay, but instead of just being one element, there's multiple elements here. Polyatomic. Poly means many. So you've mostly been seeing for ionic bonds, you are seeing a monatomic ion and an anion and a cation being drawn together by opposite charges and making an ionic bond. Nitrogen and oxygen are both nonmetals, okay? And they are both on the right side of the chart, so they can't link ionically. There's no plus or minus here. It's not ionic, it's covalent, okay? So I want to see bars, not arrows, when you draw this guy out. He's an ion, just means you're going to have an additional electron in the mix to make the elements, the elements share. But nitrogen and oxygen are not going to have a transfer of electrons in the traditional sense. Okay, so still follow all your covalent rules. So what does that mean? Okay, well, who's the center? 3 gaps, 2 gaps. Okay, nitrogen's winning. Electronegativity, least, most. Nitrogen's winning for central. And symmetry, nitrogen's winning. Okay, so you shouldn't have any issue with figuring out that nitrogen's going to be the center in this guy. And then I'm going to single bond him up. Okay, and now I'm going to count. How many electrons should I have? Well, I have 5 valence electrons for nitrogen, and there's 1 of him. 6 valence electrons for oxygen, there's 3 of them. And I have a -1 charge, so 1 more electron for 24 electrons. Okay, remember if it's a -1, electrons are negative. So that would be a plus 1 more electron when you're counting electrons. -2, 2 more electrons, plus 2. -3, 3 more electrons, so plus 3 to get your totals. All right, so my goal is 24. So I'm gonna go ahead and octet this up. Okay, so I have 2, 4, 6, 8 for each oxygen, 2, 4, 6, 8 for each nitrogen. Remember, it's only boron and hydrogen that have those incomplete octets. So this is making sense octet-wise. Let's count. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Oh, that is not my structure. Now, you could play around with process and say, okay, I'm going to increase the bond here, and I'm going to do this, that, and the other thing. But the reason why we count for ions is because that gets confusing. Some of you found this confusing with single and double bonds. For ions, it takes it to that next level. Don't try. Just recreate the wheel here. Okay, so this is the one time where you do want to recreate the wheel. So now, instead of having single bonds, I know I need to have my distribution a little bit differently. So I'm going to add a double bond. Oxygen maxes out at 2 bonds. So I know I'm not going to bring oxygen up to 3 bonds, but I know I can bring him up to 2. And now I'm going to do the same exact thing, fill in for octets. But now oxygen's starting 2, 4. So he only needs 6, 8, 4 electrons, or 1, 2 unbonded pairs to make my octet. This oxygen still needs the 6. Okay, 2, 4, 6, 8, 3 unbonded for, let me make these thick now that I added those stray marks. Okay, 2, 4, 6, 8 to make the octet. This guy's still a single bond, so same thing. 2, 4, 6 are 3 pairs of unbonded for 1 bonded to make the octet. And so now when I look at nitrogen, 2, 4, 6, 8. Oh, great, so he meets the octet. Just close your eyes right now to the fact that we have nitrogen with 1, 2, 3, 4 bonds when he only has 3 available. Remember, some shifting of valence electrons can happen. So he shifted his lone pair away so that he could have an additional bond there. Okay, now, this is still a guess. You still got to go back and count because you could still be wrong. You could still have to up another bond to a double bond. You might have to up another bond to a double bond. You could have to keep going around until you've maxed out. Okay, so still go back and check. Do we have 24 now? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Okay, we do have 24, so we can stop here. You have to do these checks or else you're going to end up either missing some of your outer electrons or missing a lone pair. Something's going to happen if you don't go back and double check. Always double check. Okay, so I know I have that right, so I'm going to go ahead and add my brackets and the charge that I'm expecting, because brackets mean it's an ion. And we know from polyatomics that nitrate has a -1 charge. Okay, now let me justify, does this negative charge actually happen? 1, 2, 3, 4, 5, 6. What he's supposed to have? 1 extra, so he's a negative. 1, 2, 3, 4, 5, 6 plus 1 extra. So he's a negative. He has 1 extra electron than what's expected. 6 minus 7, 1, 2, 3, 4, 5, 6, 7 is -1. 1, 2, 3, 4, 5, 6. Oh, that oxygen's hit it nail on the head. So that's just a 0. That's okay. This nitrogen, 1, 2, 3, 4. Oh, he has 4. He's supposed to have 5. 5 minus 4 gives me with 1 less electron. So he has a positive charge. Okay, so I have a +1 and I have 2 -1s. Okay, so that's going to give me an overall charge of -1. That's what I want. So this is one structure of nitrate. In fact, you could actually come up with different ones, but your role is to just start with single bonds each and then slowly level up 1 double bond at a time until you get to what you need, or even up to triple bonds. Just go slow and each time count the number of electrons.